Welcome to Physics World Online College, where we simplify the concept of physics. In our class of today, we will consider case 5, that is angular or inclined or oblique projectile motion. In our last class, we talked about classifying projectiles into two, angular and non-angular projectiles. We discussed non-angular projectiles with emphasis on horizontally projected objects, horizontally projected motion. Now, in today's class, we will look at angular or inclined or oblique projectile motion. If you check carefully, you will discover all the questions we have solved so far, there has not been any mention of angle. So this is a unique class and unique case. So anytime you read a question and an angle is given or mentioned, or you are made to look for that angle, then you know you are dealing with what? Angular or inclined or oblique projectile motion. Please remember to share this class video with your friends so that they will know we have something great happening in this platform. Good. So let's begin talks. We said that for objects or bodies that are projected at an angle theta to the horizontal from the ground, the body will move along a parabolic path. It will reach a maximum height. It will reach a maximum height and then return to the ground as shown in this diagram below. I've explained before that once you throw an object up, that object will follow a parabolic or curved path, which we call trajectory. So the arc ABC is the trajectory of the projectile or the motion. This angle theta, we call it the angle of projection or inclined angle. U is the initial velocity of projection or the velocity of projection, as the case may be. Now, you will take note that velocity is a vector quantity. What does that mean? It means velocity has magnitude and direction. What does that mean? It means that velocity can be resolved into two components as every other vector. So we try to extract this information from this diagram. If you have the velocity u projected at an angle of projection theta, we can split it, we can resolve it into two components. One is the horizontal component of the velocity, u subscript x. Two is the vertical component of the velocity, u subscript y. And we have been using these two components in the previous classes, only that we did not use them with angle because those ones were non-angular projectile. So here there's an angle. When we resolve this velocity u at angle theta to the horizontal, us becomes u cos theta. So everywhere we have ux in the previous cases, we can replace it with u cos theta, now in inclined projection. Likewise, everywhere we have uy, that is the vertical component of the velocity, we can replace it with u sine theta here in inclined projectile. So that is the point we want to establish. So as far as this class is concerned, we will obtain the formula for time it takes to reach the maximum height, small t, now with angle. We also establish the time of flight, that is the total time, capital T. Then the maximum height attained, the range, and the maximum range. Those are the focus for today's class. So let's begin thus. As I've established, please take note of this diagram. Sometimes you are given this diagram with unknown letters written and they say identify them, call them by name, or what does this letter means. So you know that whatever is written here stands for the initial velocity of projection. This arc represents the trajectory. This angle is the angle of projection. This height, vertical distance, this vertical distance represents maximum height, h max, and then this A to C represent the range or horizontal distance. So that question will be answered correctly. So let's continue by saying, if we are asked to look for the time to reach the maximum height for this object, the time it will take to reach the maximum height, that is half the journey. And like we established, the time to reach the maximum height is also the same time it takes from the maximum height to reach the ground. And I want you to know that this line AC, we call it the what? Horizontal plane or horizontal projection plane, or we call it the plane of projection. So when you see that in the statement or definitions that we will give, you know we are referring to AC as the horizontal plane of projection. Good and fine. So we continue. The time it takes to reach the maximum height. Time taken to reach the maximum height. To reach the maximum height, small t is given by, let's do a little retrospect. In our vertically upward motion, case 1, we talked about time to go up as u over g. That's for case 1. I want you, and I said in that class, that this u actually means uy over g. So now, in inclined projectile, uy is u sine theta. So I'm going to replace uy with what? U sine theta. That gives me that t is equals to, in place of uy, I put u sine theta over g. This formula is used to obtain the time it takes to what? Reach the maximum height. Now there's angle, so for inclined projectile. So when the object is thrown at an angle, the time it takes to reach the maximum height is u sine theta over g. And like I said, you will note this is the same as the time. Is the same as the time taken for the projectile to return to the ground, to fall to the ground, to fall to the ground. So if that's what the question wants, half the journey, time it takes to fall to the ground is at an angle, is the same u sine theta over g. Then for the next one, if we know the time it takes to go up, we can always get the total time, which is the time of flight. Now here, they want you to know the definition of time of flight. So I will take that definition. Time of flight, which is capital T. So the time of flight is defined as, this is the time required for a projectile to return to the same level from which it was projected. So the time taken for this projectile to reach the maximum height and comes to the point of projection, the original projection plane, that total time is called a what? Time of flight. So if they ask you to define time of flight, this is the definition. And then by formula, if we recall, total time is 2 small t, which means the total time is 2u sine theta over what? Over g. 2u sine theta over g. So we use this to obtain the what? To obtain the time of flight. So if they say find the time of flight for an angular projectile, you say t equals 2u sine theta over g. And as usual, if you have calculated the time it takes to get up, you can just say simply 2t and you will get that. Of course, I could have also used this expression for this total time to obtain the total time. I could have used this expression for that non-angular projectile. We said that total time, so I'm using O, is 2u over what? G. And like I said, this u is actually uy over g. And if we replace uy that is inclined at an angle, you will have it as what? T equals 2u sine theta over g. So you have the same thing for the time of flight. So the next one is the maximum height. Once again, they want us to know the definition of maximum height. You should be able to define the maximum height. So the maximum height H mass, if you look at this diagram, it is very easy to remember the definition, is the highest vertical distance attained as measured from the what? Horizontal projection plane. This is the highest vertical distance attained as measured from the horizontal projection plane. That is a what? Maximum height, highest vertical distance as measured from the horizontal plane. How do we calculate? How do we obtain the formula for the maximum height? To obtain the formula for the maximum height, we have, if you recall, for the case 1 as well, an object that is thrown vertically upward, we have that the maximum height there, H max, is given as u square over what? Over 2g. That's for the non-angular projectile. Now, this u is actually uy square over 2g. Now, we will replace this uy with this u sine theta. And this will give us that H max is equals to u sine theta all squared divided by 2g. So if you open this bracket, this square, it will give you what? U sine theta multiplied by u sine theta divided by 2g. And of course, that will give you that u max, H max is equals to u times u is u square. Sine theta times sine theta is sine square theta over 2g. And that is a formula for looking for the maximum height attained by an inclined projectile. So we call this equation C. Now, I normally prefer to express this when I applying it, especially, you can express it as H max is equals to u squared sine theta all squared over 2g. This will enable students whose maths is not that strong to be able to substitute very well and square before multiplying by u square, in order not to have problem with this interpretation. So we can use that one to solve problems for the maximum height. Then we have to obtain the range, which is the horizontal distance. Once again, they want us to know the definition for range. So we need to know the definition for range. So when asked, you are able to define the range. This is the maximum horizontal distance. Maximum horizontal distance from the point of projection to the point where the projectile hits the projection plane again. Hits the projection plane again. That is the range. That from the point of projection to the point where the projectile hits the projection plane again is called the range. Now, how do we obtain the range? Once again, you remember for the upward motion, vertically upward motion, we have a formula for range, and that formula says range is u times t. Now, I also mentioned in that class that this u is actually us times t. And now we have known here that that t is actually ux times uy over what? Over g. And I mentioned it in that class. So you see the reason now why you have to distinguish this u in range, that this velocity is actually what? The horizontal component of velocity, which is not zero, which is not affected by gravity. Good and fine. So here, if we do that, I'm going to change this t. Here I'm going to change this t with capital T, total time, because for this motion now we are considering the object move full length. So let me replace this. Let me replace it with capital T. So let me replace it with capital T so that it will be easier for us to attain. So range is actually now us dot capital T. Why am I using capital T? Because I'm considering the full length of projection. So the range is us times the time of flight in this case. Good and fine. So our horizontal component is range. This is u cos theta times t. Take this note of this formula. There are questions that apply this formula on its own to solve. We will check it in subsequent classes. Then if we continue, we have that the range, in place of total time of flight, I will put 2u sine theta divided by g. Now we have that the range equals u, we multiply u, that gives me u squared. I will have 2 cos theta sine theta divided by g. Now, there is a trig identity or ratio here. If you press your calculator, let's assume that theta is 30 degrees. If you press cos 30 and then press sine 30 and multiply both together and multiply it by 2, you will discover that it will be the same thing as sine 2 theta. So I say from trig ratio, that's trigonometric ratio, from trigonometric ratio or identity, we have that 2 cos theta sine theta is actually the same as what? Sine 2 theta. So which means in place of 2 cos theta sine theta, I will replace it with what? Sine 2 theta. I've told you to assume that theta is 30 degrees and press your calculator. Cos 30 sine 30 multiplied by 2. You will get the same thing as sine 2 times 30, which is 60. Sine 60 will give you the same thing, telling you that this identity is correct. So I will replace this u square. In place of 2 cos theta sine theta, I put sine 2 theta divided by g. This is what I will use to calculate or obtain my range for inclined projection. So you will see that there is angle in this case. Now, once we know the range, they can ask us to find the maximum range. Now, the maximum range is obtained only when the angle of projection is 45 degrees. That's a very popular question. They tell you at what angle of projection is the range maximum. So maximum range is obtained when the angle of projection is 14. Maximum range. We call that arrow max. So I say this is obtained only when the angle of projection is 45 degrees. So we say once theta is 45 degrees, the range will be maximum. So we are saying that is at theta equals 45 degrees, arrow will become arrow max. So we will substitute it into this formula and see what we are going to have. So we have arrow max equals u square sine 2 theta over g. So I have arrow max equals u square sine 2 times 45 over g. And if you 2 times 45 is 90. 2 times 45 gives you 90. And if you press sine 90, it will be 1. So we will have that the range, the maximum range is u square sine 90. And like I say, but sine 90 is what? 1. So I will replace it and say but sine 90 equals 1. So I will have the range maximum is u square times 1 over g. So u square times 1 is u square. So that gives us that the range is maximum equals u square over g. So this is what we use to obtain the maximum range, u square over g. And like I've said, it's only possible when the angle of projection is what? 45 degrees. Good. We can apply these equations now to solve this example 5, and thereafter you will solve this classwork as an assignment. So let's run through and see how we apply these formulas. Let's see how we apply these formulas to solve questions. So we have solution to example 5. Solution to example 5. We are given that a ball is projected at an angle of elevation. So you see now there is angle. Like I said, all the questions we have solved, no angle has been mentioned. So this one has angle, telling you that it is inclined what? Projection. So it's projected at an angle of 60 degree. So our theta here is what? 60 degree with a speed or velocity 100 meter per second. So u is 100 meter per second. G is giving us 10 meter per second square. So we're asked to calculate the following. Option A says find the time it takes to reach the maximum height, that is small t. So we have that small t from equation A is u sine theta over g. So we substitute our value. U is 100, sine theta is 60 over g is 10. Sine 60 is 0.866. So if you multiply it by 100 and divide by 10, or you say this 0 cancel this 0, we have 10 times 0.866. That will give us what? 8.66 seconds as the time it takes the object to reach the maximum height. Then option B says we should find the time of flight. That's capital T. So the time of flight we said is 2u sine theta over g. We substitute our values once again. That gives you 2 times u is 100 sine 60 for theta over 10. This gives us t is equals to 200 times 0.866 over 10. 0 cancels 0, that's 20. 20 times 0.66, that will give us 17.32 seconds as the total time. Once again, we could have obtained it by just simply multiplying small t by 2. That gives us the total time or time of flight. Option C, for us to obtain the maximum height attained by the object, we have that h max is equal to, from equation C, is u square sine square theta over what? 2g. Please remember to put 2g here. If you use only g, you will be marked wrong. So this will give us, we substitute. I told you I prefer to express this way so that it will be easier when you are substituting. So I will use this sine square theta will now be expressed as sine theta all squared over 2g, so that my substitution will be easy for me and everyone who may have problems with mass. So if we substitute our value, u is 100, so we have 100 squared sine 60 all squared divided by 2 times 10. So this gives me that h max is 100 squared is 000. That's 10,000. Sine 60 is 0.866 all squared. So this is giving us the right interpretation of sine squared theta. You will do sine the angle first before you square it. It's not for you to go and square 60 as some students will want to interpret. That's wrong. Not for you to square 60 first and then take sine of it. No. You take sine of the angle first before you what? You square. That is the correct procedure. Over 20. So this gives me h max is equals to 10,000. This square is 0.75 divided by 20. If you multiply out, you have 375 meter as a what? As a maximum height. Please, you have your access to calculator. Press it and then confirm that the answer is correct. Then we are asked to look for the range covered. Look for the range. So to get the range, we quote our formula equation D the range R is u squared sine 2 theta over g. So we substitute our value. This will give us our u is what? 100 square sine 2 theta means 2 times 60. So you put this in bracket over 10. Do you get that? So there is difference between sine 2 theta and sine square theta. They are not the same interpretation. So sine 2 theta means you multiply the angle first by 2 before you take sine of it. So this will give me R is 10,000 sine 120 divided by 10. So that is different from this. This one is you take sine the angle first, you square the value. But this one is you multiply the angle by 2 first before you take the sine. So you get that clearly. So this gives me 1000 times 0.866 divided by 10. So that will give us that the range is 866 meter. Horizontal distance, range is in meter. Good and fine. Then we are now told that if the angle of elevation is now 45, not 60, calculate the what? Maximum range. Maximum range can only be obtained at angle of projection of 45 degrees. So if it's not 45 degrees, it is not maximum range. So we say arrow max at theta equals 45 degrees. Arrow max. Now, two ways you may want to solve it. You may want to solve it by applying the formula of range and then substituting the angle 45, or you may just want to quote that the maximum range is u squared over g. Any one you do, you are right. Let me do both. So we have that I can quote u squared sine 2 theta over g. So which means I'm saying 100 square sine 2 times 45 over 10, which means 10,000 sine 90 over 10. And like I said, sine 90 is what? Is 1. So that gives you 10,000 times 1 divided by 10, giving you 1,000 meter. So the maximum range is 1,000 meter. Or you simply quote directly. You simply quote directly that maximum range is u squared over g. That will also be acceptable by the examiner. You say, oh, maximum range is u squared over g. Quoting this formula already assumed that the angle is what? 45 degree. So it's understood. So you can just simply substitute your value. This is what? 100 squared divided by 10, which is 10,000 divided by 10, meaning the maximum range equals 1,000 meter. So that is how we apply all these formulas in obtaining the various quantity. Here you have an assignment just to practice given to you. Once again, you see the body is projected at an angle of 30 degrees. So there's angle that tells you it is inclined projection. So this is case 5. In case 6, we will dwell more on the departure angle or angle of projection. Please do this assignment and post your answer on the comment section. I will respond appropriately. Thanks for listening. Bye for now.